right. Welcome again to Wasm I. Woo. And let's give another round of applause for Sergi for organizing this for the third year. Woo. All right, are you excited?
Yes!
Are you excited? Yeah, come on. Woo!
Whoa.
Louder. Woo! Okay, let's
Good vibes. Come on, wake up. We are in Europe.
Let's put a stop to that. So, are we enterprise ready yet?
But, Edoardo, thinking about this title, I started to think, what do you mean for enterprise?
Come on, you're trying to sell us something.
No,
Look at Red
come on,
Hats.
I told you to skip this slide. Go on. No, I don't want to sell you nothing.
For now. There's a whole
Not yet.
conference. So,
Yeah, so what does it really mean, enterprise, for you?
yeah, it's a good question. I mean, I think it's different for everyone, but the first instinct when you think about enterprise is not a good place. Like, you think about white collar, black suits, neckties. So it's not great, right? Corporate drones. And then super complicated software architecture, like, design patterns everywhere.
Look, there is an abstract beam factory.
Oh, wow, a singleton.
It was just one.
It's beautiful. And then...
Yeah, and then you have crazy legacy things like Kerberos for integrating identity management and draconic systems you have to integrate too. And are they scaring you? Or do you want to know more about them?
Yeah, please tell me more.
Yeah, no worries. Just open a Jira ticket and we will answer in 3 weeks.
Cool. I'm excited. Yeah, or you think about legacy software, things that have been there for ages, you don't know how to work it, like they've been there for entire civilizations, and they're there, and you're thinking, I wonder how it works, who built it, and how? Yeah, so, but what is really enterprise for? And then we're going to give you, the perspective from a startup and the perspective from a larger corporation, and yeah, let's try to see what that means. So for a startup, a startup, it's a small company that you start because you have an idea, you have a goal, and you know that there's a void to fill in the market. And usually when you create something like this, it's because you want to work about something you care, and very often you want to do it with friends and people that care as well. So you self-select because you know that you will work well together. And even if sometimes, it doesn't mean that you will always work well together. Sometimes you will fight. But the reason why you fight is not because you hate each other, but because all of you care. All of you have a passion about that idea. In a startup, you can vibe code. I don't know if you heard about this. Vibe coding was coined by Andrea Carpati. Like using AI, generative AI, to generate code without thinking too much about it, and without really coding, just letting the AI do it. So in a startup, you can do that because you can throw that code away. And yeah, so to put it in the words of Solomon Hykes that everyone here knows, if vibe coding existed in 2008, we wouldn't have needed to create Docker. That's how important it is. Vibe coding on the server is the future of computing. Standardized vibing interface was the missing link. Let's hope vibes are up to the task. But jokes aside, vibe coding is writing throwaway code, at least to me. So it means creating code that you can, recreate and you will solidify later. So it doesn't mean you want to bring it into production. It doesn't mean you want to bring it into, it's not enterprise ready, is it? Is it? Oh, shit. All right. All right, so, but why Wasm? Why are we here? Well, we know that Wasm is portable, it's lightweight, it's secure, so it's a great technology to build a company on. It's great to build a new company on. But yeah, as long as it's portable, as long as there's no bugs in your implementation. Like this is a bug that was in WAS0, actually not in WAS0, but in a Go test cases that were compiling into Wasm, and we're assuming some platform-specific paths in the code. It's lightweight as long as you don't compile a super large binary. So that binary will also consume a lot of memory, so it depends on your workload. And it's secure, but still, that doesn't mean that your code doesn't have bugs that potentially could lead to some security issue. So, but yeah, it's not like Wasm is broken. And in a startup, we are prepared to deal with tools that are not completely done. So Wasm ecosystem is something that it's ongoing, it's something that is constantly evolving, and the tools might not be there, but we're fine with dealing with broken toys. We're actually fine with, putting them together in different ways and trying to make something new. It's actually part of the fun. And part of the fun is also to be able to share what you do with the rest of the community, creating open source code, contributing to the specs. And, well, obviously, we want to give a shout-out to Wazira and Chicory because we work on them. Yeah, there's also a T-shirt there. But also a shout-out to all of the people in the audience that are working on other WebAssembly runtimes. There's Wasm Time, there's Wasm Edge, there's Wasmer. There's people from Oracle that work on another WebAssembly runtime, Brawl Wasm, and a lot of other cool stuff. You're going to hear about that. Yeah, Wazira is for Go, and Chicory is for the JVM. But, yeah, we love all of them. But what about end users? Do end users have to deal with all of these changes, all of these fast-pacing changes? So imagine that you release a product, and at first your end users get it, like they put the square peg in the square hole, but then they don't get it. They start to put the triangle in the square hole, and they put the arch in the square hole, and you get increasingly more frustrated because they're just not getting it. And you would really love to be able to jump into that room and shake them and tell you, you're not getting it. This is great. Why you don't understand it? But you can't do that. And maybe it's not their fault. Maybe it's that your product is not clear to use after all. Why is the start button named that way? It was named that way because otherwise people wouldn't know when put in front of this new GUI what they should click. And we've made a lot of jokes in the past about how the shutdown feature was buried in the start menu. You click the start menu to shut down your computer. But the reason why it was there is it's because in user testing, people would instinctively go to the start button when they were asked, please now shut down your computer. So maybe the goal when you design a product is also to build something that is as natural as possible for your end users. And that means make it as clear as possible. You cannot ship something that's broken and tell them that it's a puzzle. So is Wasm broken? No. All I'm saying is that if you want to sell Wasm to people, maybe you don't necessarily need to sell them Wasm itself. What you really want to sell is a product that's built on Wasm. So saying that your product is built on Wasm, sometimes, not always, maybe saying the quiet part loud. What you really want to build is something, it's a solution to a problem that happens to use Wasm, and that Wasm, because Wasm gives you a superpower that otherwise you wouldn't have. So you don't want your end users to wonder about what's the best Wasm runtime. You don't want them to wonder about what's the best Wasm toolchain. You want to give them, you don't want them to find too many bumps in their road to success. You want them to find a straightforward line and guide them as much as possible, so they don't have to deal with all the changes and all the complications. So there's Fermion has Spin, Cosmonic and Wasm Cloud have Wash. And there's XTP from Dialypso to create, a seamless experience when you want to create and scaffold some project. XDism is a framework it's an open source framework to create plugins based on Wasm, but it's a layer of abstraction over different runtimes and different compiler toolchains. So you can, ignore most of those details. We built that because we felt like it was needed. Otherwise, people that weren't that knowledgeable about Wasm would find it harder for them to use. We built XTP, which is a product to allow to distribute plugins to share them with authorization, permissions, test them, and verify them. And we also build tooling for observability. But then we also built an end-user product, a product that it's actually more geared towards end users that don't care if it's built on Wasm or not. But Wasm gives it a superpower. This is a framework to do agentic stuff, and it calls function, whatever that means. It allows you to do automation and call different services. And if you don't know about Wasm and how to compile stuff, it will work for you. But if you want to dig deeper, you can customize your tools, and you can write new tools. And the superpower that you're given is that since it's Wasm, you can use the language you want, and you can run it on your machine, in the cloud, and even on a device. Debugging Wasm is still kind of a pain point. Hopefully, we'll shed some light on it. There's another session still from the Oracle guys, but also a session with Rolf. Have you recorded the session this time? and solving the problem in a general sense, it's kind of hard, can be hard. But solving it in a specific and narrow use case, it's much simpler. So we're also working on tooling to debugging function calls in LLMs, because you can just record the inputs and outputs, and the functions are relatively small. So it's a smaller target to hit. So it's doable. So the general advice, you should cater for your audience. You should ensure your product is polished for your end users. And obviously, you should endure the pain so that users don't have to. And finally, if you can narrow down the scope and solve the problems that you have at hand.
Thank you, Edoardo. This was really enlightening and a really interesting point of view of a startup picking up on WebAssembly. For me, the experience has been completely different. I work for a corporate. I work for Red Hat, where you have thousands of people. You don't have to convince 3 colleagues that WebAssembly is a good idea and you can go along with it for months or years. You have to convince tens of people or hundreds of people that WebAssembly is a good idea to be able to continue to work on it and to push it within your environment. And I can anticipate to you that it was a long and winding road to get there. So I want to share this experience with you. First of all, I have a disclaimer, because what I'm going to tell you in the next minutes is not my own opinion on WebAssembly. We can speak about it later on in the corridors, etc. But those are the point of views of people outside of this community looking at WebAssembly like external people or trying to use it. And those are colleagues and friends. And I thank them. So take those words from an outsider point of view. First of all, I got people burst. In Red Hat, everyone was trying to use WebAssembly instead of containers, and they haven't managed, basically. So they struggled a lot. And there are 3 main reasons why this happened. The first thing is that it is really hard to compile an existing code base to WebAssembly. They found it really impossible to do it with customer user code. And there is not a stable system interface, which is extremely important to build a container alternative. And there are very limited day 2 operations available for the runtime of WebAssembly. But let's go through the steps. So when you're building a container, you have a pretty much mature tooling like Docker and Podman that are out there since years. And you can actually pick things from the internet and drop them in a container. And very likely this thing is going to work somehow, maybe not optimally, maybe not efficiently, but this is going to work. And you can just grab random stuffs and put them there, and it will work. So it doesn't require that much thinking. It doesn't require to restructure your code. Instead, the experience of compiling WebAssembly on the server side, I don't know if you share, but is much more complex. So you have often to use alternative compilers with different level of maturity. And you have to use alternative tools to get the things compiled, actually. So you have to use optimizers and initializers to get your Wasm code actually running at the performance that you want. And there is a scarce documentation. Often, when using those tools, you have just to read through the code to figure out how to use a CLI. And that's pretty normal in the experience of anyone working with WebAssembly those days. And the thing is that is a new kind of problems that we are putting in front of our users up front. And this makes their life harder. And the curve to get to adopt WebAssembly becomes steeper. Then we have this thing that we always say, write once and run anywhere. WebAssembly, well, it depends. So let's start. In Red Hat, we are maintaining the packages for compiling and the tool chain for compiling things to WebAssembly. And once we say that we have WebAssembly, a new target, and this will solve all your problems, they look at you, they stare at you in a strange way, and they say, OK, another target. I mean, for people maintaining a compiler toolchain, WebAssembly is just one or more targets to add. They are not going to drop IBM Z mainframe native compilation because they need to run it to run the business. So they are not going to drop other compilation targets. And WebAssembly just goes on top of them, causing them more problems, more troubles, and more maintenance at the end of the day. So people maintaining compiler toolchain are not really happy about it. And if you look at the compilation target of Rust, you can see that already we have mscript and WASI P1 was in different flavors, and then WASI P2. They start to look very much like different operating system or architecture. So this is diminishing the value of write once and run anywhere, because you can't really write a piece of code and compile it to Wasm and run it in the browser and on the server side. You need to know a lot of things, and you need to craft your artifact in specific ways to get the most out of it. A lot of people have been scared because to integrate with Kubernetes, etc., they integrated WASI Preview 1, which is deprecated nowadays. This is good, and there is a lot of very good work going on the component model and on WASI P2 and P3, and this is super interesting. But since we have given them WASI P1 to build on, and they have found it deprecated, they are not confident into building on WASI Preview 2, because who tells me that in 6 months it will be deprecated too? So we are not giving to people a stable base to build their software upon. So that's why they are really scared about picking up even the new WASI, the new WASI implementation. That's a very, very, very different stories for people working on the front end. With things like Kotlin and Flutter, Dart, and mscript, you have pretty much streamlined tool chains that brings you from the source code to deploying it on the web, in this case, that are super streamlined, super easy to use. Again, like Edoardo was saying, if you scope down your problem and you reduce the invariants and you target one very, very specific thing, in this case is you target one specific language only, you can get out of it with really great tooling and really great things when scoping down your problem. But now, let's imagine that we have managed to endure the pain and go through the process of compiling things to WebAssembly, and we get effectively something running. So this is cool, and they have something running, and they want to bring it to production, and let's see what happens. And first off, again, we have debugging, which is something big. So if you look at the documentation of the Rust book, this is the advice. You don't have to debug Wasm at the end of the day. You can see this guy. This guy is a consultant working for Red Hat who received a phone call from a customer who is running WebAssembly in production, and the customer say, I have a bug and I have a problem in this part of the code. How do I debug it? What can I do? I mean, this is clearly not feasible for a company like Red Hat to be adopted. I mean, we can't force our customers to write correct code. They will write bugs as we do. And we will receive phone calls and requests for getting support out of their messy code. And we don't have a good debugging story so far. And if you look at the resources online, there is a living document, which is Dwarf for WebAssembly, which is extremely interesting and paved the way to actually have the debugging functionalities for WebAssembly. But you can see that, I would say that it's not living this document, it's surviving since 5 years. Is struggling to get up to date and to have new features implemented and new easy tools to be used. Let's go next and talk about observability. So more often than not, nowadays we live in fantastic times where we have tracing and everything that are working really well, tracking from the request of the HTTP request of the user to how you're using your microservices in your infrastructure and how you access databases, etc. But when you look at the observability of the WebAssembly platform that you see, you can see that they stop at the border of WebAssembly module more often than not. So WebAssembly is treated for, and for some use cases it makes sense, but not for all of them, is treated as a black box. You don't know what is going on inside. You don't have a clue of what is running inside your WebAssembly module. And that's why we really need to write performance software and to be able to debug performance issues in production and to monitor our system, to go down and drill down the cause inside the WAS module and to actually debug and understand where the time is spent in production in our WebAssembly modules. One more, we want to talk about security. To talk about security, I have to give you an introduction to a fantastic procedure or things that we have in Red Hat, which is called productization of libraries. So this means that in Red Hat, we rebuild from sources on internal CI pipelines, secure, all the software that is running on our premises and on our customers. So since we build even Linux, we can rebuild everything starting from the kernel, up compiler toolchains, and everything that goes into the application of the user, up to jars and npm packages and crates and whatever everyone is using. So this is extremely important to rebuild everything inside because we are pretty sure that we don't have secure supply chain attacks. And we can trust the software that we build, and no one has compromised the software that we are giving to our customers. The second reason why you want to spend all this effort rebuilding your entire ecosystem and your entire infrastructure from scratch is that you want to be able to react to CVEs really quickly. This means that we have always a pipeline ready to accept a patch of 10 lines on a CVE, on a critical CVE, on a bug that has been discovered yesterday, and we can release it autonomously without waiting for upstream communities or for or for our external maintainers to pick up, accept the patch themselves and release on the official sites. We can always do it autonomously, and this is extremely important to stay within very strict SLAs. And then legal, because Red Hat does all these things on top of open source software. So we have to check the licenses that are how the software have been distributed and see if they fit with what the customer is doing and if they are legal to use, actually. And this comes what is going on. So I told you that we are rebuilding everything, and we are rebuilding even NPM packages for Node.js applications and front-end applications, and for the end user. And given that WebAssembly is pretty much widespread in the front end, and this is really good, people started to drop WebAssembly into their NPM packages. And think about what I told you. So they have to verify and rebuild everything internally. Basically, people looking at productizing those packages containing WebAssembly payloads, they have to figure the Wasm out of it. So they have to figure, in the NPM package, you find a binary file, and you don't have any clue where it was built, how it was built. Probably it was built on the machine of the library author, and you don't know which compiler toolchain they used. They don't know if it belongs to a specific commit or not. What is the repository of the source code, and with what license that software has been released in first place. And this is extremely important for them to make their work effective, but they have to reverse engineer all those things for each and every NPM package, and you can see that this is hard work that we are putting on our productization engineers.
All right, Andrea, this is all good, and I'm going to let you finish, but sorry to interrupt, but do you even like WebAssembly? Why are you here? I mean,
No. Let's stop with other people's opinions. This is my opinion. I really love WebAssembly. WebAssembly is amazing, and is a super solid foundation and pillars for building our software. And it can deliver actual value really right now. So what is going on is that we can already build C code, for example. We have a Ruby parser written in C that we can run in Java or in JavaScript or in other languages. We can run Python user-defined functions inside the database based on WebAssembly. And when you have message queues, you can directly have transformation on the single message built with WebAssembly and Go in this case, and put them in production, because you can craft a very good experience for your user if you scope down your problem and you make WebAssembly basically a technical detail, a technical implementation of what you want. And the basis is solid and is super good, and it enables you to actually deliver this kind of value, which is pretty amazing for a technology.
all right, so what does it mean to be enterprise? Well, we saw a few things that are important, but first of all, how do you build enterprise software? So the way you build enterprise software is by providing good user experience, a refined developer experience, and that means provide tooling and even hide some of the details sometimes where it's better that the spikes don't show. And, well, you want good software modularity, is integration. In general, you want everyone that's going to use your product to be as comfortable as possible without thinking too much, just doing their thing. Let them solve their problem.
Yeah, building enterprise software is not just about the bad things that bad things like patterns and Kerberos and whatever we told at the start. Building enterprise software means that it has large adoption, means that everyone is using it out there, means that it can be actually employed in critical applications, making it easy to use to be used at scale by anyone, even that is not a great software engineer. I mean, is a software for everyone. Enterprise software is something that can actually be used in large corporations with very different level of software understanding. And we don't want to cover ourselves and to cover the fact that we are using WebAssembly to deliver all this value. We want to be proud of it, and that's why we are here, and we are working toward a better future together.
So are we enterprise ready yet? That's all we have.
Thank you.
Right, just one last thing. If you are interested in what MCP.run is and you want to learn more, there's a workshop happening downstairs after lunch. So I'll see you there. Bye.